NASA and the European Space Agency have finally released the official high-resolution images from the Mars flyby of 3I Atlas. And I must tell you, as someone who directs the Galileo project and has studied these interstellar visitors intensely, these images have fundamentally shaken my understanding of what we thought was possible. Because what we're seeing in these photographs doesn't just challenge our assumptions about comets or interstellar objects. It challenges our very definition of what constitutes natural versus artificial phenomena in our universe. The Mars Reconnaissance Orbiter's HiRISE camera, the most powerful telescopic instrument we've positioned beyond Earth, captured 3I Atlas during its closest approach on October 3rd from a distance of just 18 million miles. That resolution reveals details smaller than a football field, and those details are unlike anything we've encountered before. Let me walk you through what makes these images so profoundly disturbing. When we photograph conventional comets approaching the sun, we expect certain predictable features: a bright central nucleus composed of ice and rock, a fuzzy coma surrounding it formed from sublimating gases, perhaps dust jets streaming outward from active regions heated by solar radiation. These are the hallmarks of natural cometary behavior, patterns we've observed thousands of times throughout astronomical history. 3I Atlas displays none of these expected characteristics. Instead, the high-rise images reveal something that looks almost manufactured in its precision. The primary structure appears geometrically regular in a way that natural objects simply should not exhibit. Where we expected irregular, potato-shaped morphology typical of asteroids and comet nuclei, we're observing smooth surfaces interrupted by what can only be described as distinct features. This is a critical point. In space, objects are shaped by two main forces: gravity, which pulls things into spheres over time, or chaotic collisions, which create irregular tumbling shapes. There is no non-natural force, not accretion, not solar wind erosion, not gravitational tidal forces that sculpts a complex object into a perfect symmetrical tripod. Three separate protrusions extend from the main body at nearly perfect 120-degree intervals, creating this tripod configuration that defies random formation through accretion or impact processes. Each protrusion measures approximately 1.24 miles in length, tapering toward the ends with mathematical precision. But here's where the analysis becomes truly unsettling. Spectroscopic data overlaid on these images reveals that those three protrusions are not composed of the same material as the central body. The main structure shows albedo characteristics consistent with carbon-rich compounds, absorbing most incident sunlight and appearing dark against the background of space. Yet those three extended features, they're highly reflective, almost mirror-like in their surface properties. They're bouncing back solar radiation with an efficiency that exceeds 90%. This is comparable to polished aluminum, or perhaps more tellingly, precisely engineered solar panels or a solar sail designed for propulsion. Dr. Sarah Chen at MIT's Kavli Institute performed a detailed photometric analysis that was published just this morning. Her conclusions are stark and unavoidable. The reflectivity pattern, she writes, is inconsistent with any known natural mineral composition. The surface appears optically smooth at wavelengths down to 200 nanometers, suggesting manufacturing precision rather than natural crystallization. The European Space Agency's Mars Express captured complementary images from a different angle approximately 18 hours after the high-rise observations. Those images confirm that the geometric features maintain their configuration regardless of viewing perspective. This isn't an optical illusion or an artifact of imaging angle. We're looking at genuine three-dimensional structures attached to or integrated with the primary body. And here's perhaps the most troubling detail. Those reflective protrusions appear to be oriented specifically toward the Sunday. Right now, at this precise moment, something extraordinary has just unfolded. After weeks of unexplained silence, after mounting pressure from the scientific community and growing public speculation, NASA and the European Space Agency have finally released the official high-resolution images from the Mars flyby of 3I Atlas. If these images are so extraordinary, if they genuinely suggest artificial origin, why were they delayed for 3 weeks? Why the silence from NASA, ESA, and CNSA following the October 3rd flyby? The official explanation points to the government shutdown that began October 1st, just 48 hours before the encounter. NASA operations were severely restricted. Public communications were frozen. Data processing pipelines slowed to a crawl. But here's what troubles me about that explanation. The high-rise camera is automated. It captured these images on October 3rd. Regardless of government funding status, the data transmitted to Earth was immediately received by the Deep Space Network and archived in NASA systems. Yet, the release didn't occur until October 24th, 3 full weeks later. Even accounting for bureaucratic delays, even acknowledging that image processing requires time, that gap feels excessive for an event of this magnitude. I spoke with several colleagues who work within NASA's Planetary Science Division. Off the record, they describe unusual internal discussions, questions about public reaction, debates about how to frame this data, concerns about premature speculation, spiraling out of control. We spent 3 weeks, he said, trying to find natural explanations that could account for what we're seeing. We failed. This pattern isn't unprecedented. When Oumuamua accelerated mysteriously away from our sun in 2018, certain spectroscopic data remained unpublished for months. When Borisov arrived in 2019, despite its more conventional appearance, some trajectory analyses were withheld from immediate release. Each time an interstellar visitor displays unexpected characteristics, information flow slows down, becomes more carefully controlled. Perhaps that caution stems from legitimate concerns about public misunderstanding. Or perhaps it reflects something deeper, an institutional recognition that we're approaching revelations that could fundamentally alter human civilization's self-perception.